Hello, and welcome to the Astrolabe tutorial series. In this video, I will discuss how to set up differential expression analysis for your experiment. This video will build on material presented in other tutorials. If you need a refresher, you can find links to tutorials about experiment setup, using NA values for conditional analysis, and differential expression analysis below. In Astrolabe, differential expression analysis is a tool we use to examine how markers change in expression across different populations of interest. For this demo, we are going to use a publicly available dataset from Glassberg et al., which used an ex vivo model to mimic the effects of thrombosis on a control and a patient group with sickle cell disease. There are several features of interest in this experiment, including control and patient samples, pre- and post-implementation of the model, and 3 time points at 10, 30, and 60 minutes when samples were taken. So let's set up this experiment for differential expression analysis. I have already uploaded my FCS files, and I'm going to start by picking out a few features right from my file name. So the first is patient, and for that I have 3 control and 3 sickle cell patients. I'm going to add condition, which can be either pre or post application of the system. And finally, I'm going to add time point, which can be either 10, 30, or 60 minutes. Now I want to add a few more features for differential expression analysis. To speed this up a bit, I'm going to download the template and work from there. First thing I'm going to do is simplify these sample names, just to make them a little more succinct because they will appear in some figures later. So I'm just going to concatenate patient, time point, and condition together. Then let's add a group for our sickle cell patients and control groups. The next thing I'm going to do is add a feature for each time point, so I can compare them separately. So time point 10, time point 30, and time point 60. Now, for differential expression analysis, I am essentially trying to compare my patient and control groups. More than that, I am particularly interested in comparing my patient and control groups after the application of the ex vivo model. And actually, even more than that, what I'm really interested in is how my patient and control groups each responded to the ex vivo model from a baseline. So with that in mind, when I fill in these new columns here, I'm really only interested in analyzing the post samples for each of the identified time points. So for time point 10, I'm only going to fill in values for my patient and control post samples for the 10-minute time point. Likewise, I will do the same thing with time point 30 and time point 60. Everything else I will set to NA, which will exclude it from analysis. So this is looking good, but I still have not set up differential expression analysis. This is important to do now, because I can't just go back and add it after I've analyzed the experiment. So I will click on Analyses and Add Differential Expression Analysis. For my first analysis, I'm just going to go ahead and pick time point 10 as the primary feature. And you can see this automatically populated the name of the analysis as well. I could change that if I wanted, but I'm going to keep it. Next, we'll choose a baseline for this feature. And if we think back to this equation, what we're really talking about here is the denominator. So in this case, I'm going to use control as my baseline. Then, for dependent features, again, the pairwise analysis that I want to perform is pre and post the ex vivo model for each patient and time point. So for dependent features, I'm going to select patient and time point. Now, for the reference feature, we're talking about this part of the equation. If I didn't have a control or a spike in to use as a reference, I could leave this blank. But since this experiment has a pre-sample for each patient and control, that is what I'm going to use as the reference. Okay, almost done. Now I'm going to pick some markers. I do want to be somewhat judicious about this because of multiple testing correction. So I'm really only picking the markers that I think might change. Finally, I'm going to choose a marker statistic, which is the aggregate statistic Astrolabe will use to calculate the intensity values we want to compare. The default is the 95th quantile, which is the most sensitive method, which focuses on the long tail of distribution. So I'm going to keep that. I'm happy with this. So I'm going to go ahead and save time point 10. I'd like to do the same thing for time point 30 and 60, and there's actually a really easy way I can do that. I'm going to hover over time point 10 and select the copy icon. Now I can open my copies, change the primary feature to time point 30 and time point 60, and I'm ready to go. Next in this series, I will show how to navigate the results of differential expression analysis. Remember, if you have any questions, you can always email us at support@astrolabediagnostics.com.